2. 2, 3. All right, so the first thing I suggest you do, even though you have them in there, is maybe take out a piece of paper and write these down so you have them beside you when you're working through your questions. So I would suggest taking a blank piece of paper out right now, this piece of paper, and write out all of these, they call them key ideas. I'm just going to call them the exponent ones. So you do not need to write the examples out per se, but what I would suggest is I'm going to give you 1, 2, 3, 4, 5, 6 laws that you want to have on that piece of paper beside you. Don't write them down until I leave it up. I need you to see examples. It's going to be easier to learn and remember these if I show you examples on the board. Yes, sir. No, 4.2 Jimmy. Keep going. Right there. These 6 guys. Don't write them down. Just go with at the same pace I go at. Otherwise, it'll make no sense to you whatsoever. So let's just go at the same pace. All right. First of all, 2 cubed times 2 squared is 2 to the what? Yes. What is it?
2 to the 5.
2 to the 5? You telling me I add the exponents together?
Yeah.
Yeah? We sure?
Yes.
All right. I agree. 2 cubed is 2 times 2 times 2. Agreed? 2 squared is 2 times 2. So when it's all said and done and I multiply it together, how many 2's do I have?
5.
I have 5 of them, right? So 2 to the 5th. So the first exponent law that you want to write down is simply this. A to the m times a to the n is equal to a to the m plus n. All that says is that when you multiply these things together, as long as they're bases, okay? So first of all, we should identify that. This is referred to as the base. That's referred to as the exponent. So if the bases are the same, you simply add the numbers together, okay, in order to get this base to that many exponent. So 2 to the 5th is the correct answer, okay? Add the exponents together. All right, that's exponent rule number 1. If I have this, what does that equal to? Any ideas? I want to take a guess.
31.
What do you got?
31.
31? You added those two together? Not bad. I like it. Okay, that's what I was looking for. I don't like that answer, but I'm glad you said it. That's awesome. We do not at any time multiply these two guys together if there's exponents. Okay, so do not do that. So that's great. I'm glad you said that. Okay, that's the one mistake I don't want to see made, and it gets made. I can't do anything with this. This essentially is 4 times 27 dot add. Okay, that's basically what it is. So what is that? 8 to 8, 108. So that's your answer for that question. Bless you. Okay, you cannot multiply the bases together when they're different. And you don't multiply the bases together when they're the same either. Do not multiply the bases together at all. Okay? This is not 4 to the 5th. It's 5 2's. Okay, so I'm just going to show you some errors that get made as we go. All right, so now let's take it another level here. 4 to the 5th over 4 cubed. What do I get?
4 squared.
4 squared. agree? Does that look right to everybody?
Yes.
Yeah? Okay, so now, the easy part with this, if I'm multiplying, I add the exponents. If I'm dividing, I subtract the exponents. That's essentially what it is. If I were to expand this now, what would this expand to? Well, 4 to the 5th, correct? 4 to the 3rd, right? When I divide anything by itself, what do I get? 1. I get 1, right? So if I divide those by those, what am I left with? 16 or 4 squared. That's right. So you see how that works? So I just simply subtract the exponents. The easy way is to subtract the exponents. You can expand if that makes it easier for you. You can expand it. All right, that is something that you can look at. All right, so if I have a to the m over a to the n, and again, those bases have to be the same for the rule to apply. That is a to the m minus n. Okay, let's start this class over again because I don't like it. Shut your phones off because somebody's beeping back there. So anybody's got a phone back there, get back there and shut it off. I don't want it to vibrate, I want it off. You got a phone in your pocket, put it on the back shelf and shut it off. Okay? We want no phones in here.
A barrel's gonna explode. I've been eating too many crackers. I feel like Piglet, or no, Winnie the Pooh.
All right. Okay. Thank you. Hi. Go get him. Go get him. Go get him.
Okay, hurry up. Let's keep going here. All right. 2 squared to the power of 3. To the what? 6. How do we know that? Because I multiply the exponents. If I flip the page over, would you guys have known that?
No. Or
We knew that last year. Done this last year? Okay, good. So I had 2 to the power of 6. Now, that is saying 2 squared by 2 squared by 2 squared. Do you agree? Yeah. That's what that means? Okay. How many 2's do I have here? Here.
3, 1,
Here.
1, 2.
2. Here. 2. So that means I have 2 to 6. Alright, we're good so far. So we have done some of this last year. Okay? So then the rule then is when I have an exponent to an exponent, I multiply them together. Okay. I'm going to backtrack us just a little bit here to take you back to yesterday's work. Okay? I had the square root of, well, let's do 16. What is the square root of 16? 4. Square root of 16 is 4. 16, you would agree, is 4 squared? Everybody agree it's 4 squared? Yeah? And the square root written as an exponent is what? 4, 3. I told you this yesterday. What is the square root written as an exponent? 0.5. 0.5. Okay, I can work with that. 1/2. Right? So now, I set this up for you yesterday on the board. What do I do when I have an exponent to an exponent? What do I do with the exponents? I multiply them. What is 2 times 1/2? 2 times 1/2 is 1. So that's 4 to the 1. That's how I get 4. Okay? We want to remember that. Because we're going to do that in a day's time. That these guys we're gonna rewrite as exponents instead of root values, okay? But this principle goes with that rule right there. Exponent to an exponent, you multiply. Okay?
How did we get the half from?
The square root is an exponent of half. If I have a 3 there, it's exponent 1/3. If I have a 4 there, it's an exponent of a quarter. Okay? We'll come back to that. I just wanted to show you that we did it yesterday. Product, quotient, power of a product. Okay. So I'm gonna go a little more than 6 because I see this one's in here. I wouldn't normally do this, but we'll do it anyways. This came up yesterday as well. If I have a times b to the m, okay? A times b to the m. What happens here if I wanted to expand it? Yeah.
A to the power of n and b to the power of n.
Yes, very good. A to the power of m, b to the power of m. Okay? So you transfer it through on every value inside the brackets. Okay? Yesterday we did see this. Want to see the example from yesterday that we saw this? It was this guy right here. Except it's the next rule that we're going to use. We had this yesterday. This was one of our questions. Okay? So to rewrite this with expansion, this becomes 5 cubed over 7 cubed. 125 over 7 cubed. Anyway, what do you got? 243? 343. Thank you. 343. Okay? Everybody's okay? That was yesterday's question. So that leads us into today's rule as well. Simply get rid of your brackets and put the exponent on everything inside the brackets. Okay? And it's going to get complicated, trust me. It gets complicated because then I'm going to put numbers in the brackets with exponents, and you got to, so it gets busy, more so than complicated. Okay? Everybody's all right so far? So again, we've all done this last year. How many of us remember some of this from last year? How many do not remember a stitch from last year? At least you're honest. I like it. Good enough. You guys following today then?
Yeah.
Okay. Okay. All right. What about this guy? Zero. E to the 0 is what?
1.
1. Okay. Any value to an exponent of 0 is equal to 1. Okay? Let me show you why. Again, I believe in showing you why and the hows so that you understand it better. So here's why. If I have 4 to the 3 over 4 to the 3, what do I do with the exponents?
Take them away.
I subtract them. So what is 3 subtract 3?
0.
0. If I were to expand this though, what does it expand to? 4
times
4 times 4, correct? Yeah. 4 times 4 times 4 down here, right? What does that equal? 1. So anytime you have an exponent of 0, the value is automatically 1. And that's why right there. Because you're basically canceling anything on the top and the bottom. It equals 1. So far so good? Here's the one that gets everybody. So this is it. This might be one you didn't see much of last year or at all. Are we okay so far? Let me just quick review for you so that so the first one was adding the exponents, right? Second one, subtract the exponents when you're dividing. Third one, multiply the exponents when you have an exponent to the exponent. Fourth one and fifth one are distribute through the brackets. Sixth one is a to the 0 is 1. Here's the one that this one causes so much grief, and it really shouldn't. You good enough?
Yes.
Here's how it works. A to the minus m. I want to write that as an exponent with a positive value. Okay? In order to do that, I do one simple step. I just simply put a 1 over it and move it to the bottom, and it becomes this. 1 over a to the m. Okay? Alright. Everybody follow me so far? Now I'm not going to give you an example on this. I'm going to do it the other way. So if I have 1 over a to the m, I can move it back up to the top, and it becomes a to the minus m. So far, so good? Okay? Alright, so let's look at how come and why. Here's what happens. 4 times 4 times 4 over. So in other words, I want 4 to the third over 4 to the fifth. What is 4 to the third over 4 to the fifth?
16. 4 to the negative 2.
4 to the negative 2, because I subtract my exponents. I get 4 to the negative 2. Do we all agree with that? What do I do with the exponents when I'm dividing? I subtract them. And what is 3 subtract 5? Negative 2. We're all okay with this? Alright. When I cancel, so in other words, if I want to turn that into a positive exponent, I go 1 over 4 squared. Okay? So I turn it to a positive exponent by putting 1 over top of it. So far, so good? Watch what happens here. Those 3 cancel with those 3 right there. What am I left with? 1 over 4 times 4, which is 4 squared. So that's why, when it's a negative, I can move it to the bottom and make it a positive. Yes, Brock?
Why does that 1 stay here? Like, where does the 1 come from?
Where does the 1 come from, Brock? Brock, what's 5 divided by 5? what's 6 divided by 6? 7 divided by 7?
1.
How about 64 divided by 64? I got 1 here, and 4 times 4 on the bottom. Does that make sense? Anytime you divide by a number, you have to have 1 left over. Right? So that's why. Hey.
You draw a graph, that's all. I'll just.
Oh, sure. Oh, is that on that thing?
Yeah.
Did you print it off?
Yep.
Okay, I'm sorry, I couldn't print it off. Yeah, that's all right.
I'll set it.
Okay, awesome, thank you. Okay, so does everybody understand that? That's the one concept that just kind of is tough, where we just kind of can't wrap our head around it. Okay, so let me do something different here. Let's give you a couple examples, and you tell me what to do in order to make it positive, okay? So I've got, are you ready, sir? 3 over. How do I make that positive? Go ahead, Alexander.
You flip them and then, like, the 2 would be positive.
Okay,
Like,
that's,
the 1 to the
yeah, I
fifth.
don't mind that. You know what? I'm okay with that. I wouldn't necessarily say that, but I like that. Alexander says, flip the fraction, which in mathematical terms is reciprocate. So change the top with the bottom. That's what it means in layman's terms, right? And then make the top positive, the exponent. So he says, do this. Sure. Perfectly right. Okay? It's 100% correct. Just change it, take it from the bottom of the fraction and move it to the top, and it changes the sign on the exponent only. On the exponent only. If I had, I'm just gonna throw this at you. If I had this, if I have that, it still remains a negative, but the exponent changes. Give me grief. So that's what it becomes. Okay? There's the one mistake that gets made lots. There's the one mistake that gets made. They get rid of the 3 when they move. You don't do that. It can only change the sign on the exponent. Okay? How are we doing? Okay? So you should have about 7 rules on that piece of paper right now, right? 7 or 8? So let's look at some example questions then. Start with the examples on the page here. Okay, they get right into it. There's no messing around right away here. All right, right? Each expression is a power with a single positive exponent. So here's what I have. 0.4, -2, over 0.4 to the 2, all in brackets, gives me 0.4 to the 1. What is it? -4. -2 subtract 2 is -4. Now, I'm not testing you on your integer skills because they're going to be a little bit lousy at this time of year. So if you have to use a calculator to subtract -2, subtract 2, go ahead. I'm not going to stop you. I don't believe in it. I don't like it, but we're not teaching. I'm teaching you radicals. I don't care if you can add or subtract integers. So the long and short of it is, you're absolutely right. This is -4. But that's not as a positive exponent. So how do I make it a positive exponent? Put it underneath 1. That's correct. So that becomes 1 over 0.4 to the 4.
Because you never want a negative exponent.
No, it's asked for that in the question. Okay. Positive exponent in the question. Okay. So this is on your first page. This is on page 66. This example on 66. Okay. Next. 6 to the 4th. 6 to the -2. Write out your answer. Write it out. Don't yell it out. Don't yell it out. You wait 10 seconds to figure it out. So this is why I have my rules beside me. I look at my rules, and what does it say when I have 2 terms multiplied by each other with the same base? What do I do with the exponents? Add the exponents. So what's the correct answer here? 6. 6 to the power of 2. There's your answer. Okay? Again, have your rules beside you when you go through this. It makes it a lot easier. Kylie.
So if we had a question like this, will we have to write it out as 36, or do you want to just to stay?
You write, oh, I see, yeah. No, this specifically said write it out with an exponent with a positive value. Look at your question. Read the question. It's at the bottom of the page there. On page 66.
I'll write the expression with the power with a single
Yes.
positive exponent.
If it says that, that's the correct answer. If it doesn't say that, that's the correct answer.
Okay.
Okay, great question. How are we doing so far? Okay? All right?
Well, they turn some bunch of brackets.
The next one's
Oh, wow.
All right.
2, 4,
Well, that's a -3 as well. That's -3.
That's for majority.
3x.
Hold on a second here. One line.
It's probably not right.
All right. So what do we see in here?
Confusion.
2 brackets. Well, realistically, there's only 2 brackets, right? Brackets implies the first and the last, which would make 1. And And then the square guys would make 2.
That's
4
the same.
parts to 2 brackets. You agree?
What do you want me to say, 4 brackets?
There's only 2 brackets here now. 1, 2.
4 parts.
There we go. We're on the same page. Alright, what do you think I should do first?
Multiply.
Times -2 times -3. I like that. Let's get rid of one set of the brackets. So that's 3x to the power of what now? Positive 6. How come?
Negative.
Justin?
Negative and a negative equals a positive.
Okay, and what did you do with them? You multiplied them, right? -2 times -3, that's how I got the 6. You okay? Now what do I do with that 6?
Put it into both.
Put it into,
Put 3 in there.
distribute it, put it into both, you guys are both right. 3 to the x, 3 to 6, x to the 6, done.
And that would be the answer?
That's your answer.
Why am I so bad?
Yeah, it really is. But it looks confusing when they start setting some of these questions up for you. Lots of brackets, whatever else.
13 brackets.
How are we doing with this?
Pretty good.
No.
I still feel lost. Jamie, a little bit lost on this? Okay. Cameron? So you're half asleep. Alright. Let's look at a few here. Okay? Then let's start. I'm gonna start 1 with you guys. And we'll work through it together and then we'll let you go. And actually I have to look at yesterday's book too. Okay. Write each expression. Jamie, write this as a positive exponent. What do I gotta do? You have your rule sheet. Yeah. Yeah. So look at the negative part of it. So that's up here. Okay, how did I make this a positive? How did I change the -5 to a positive? What did I have to do with it? Going from here, you just look at this part right here. That's all I'm asking. How do I make that, turn that negative into a positive? Yeah, put it underneath the 1. That's it. Okay, so what's the answer here?
1 over 4 to the 2.
Yeah.
Could you do B too? Just
Sure. Okay. Questions? Who could have got that right? Who would not have got that right? Be honest. Okay, it's the rules thing. That's okay. That's what I need to see. Alright? So do you understand? Okay, so all I gotta do is I draw myself a line. If it's negative on top, I move it to the bottom and make it positive. If it's negative on the bottom, I move it to the top and make it positive. Just draw a line, put it down here, I'll put it up there. Make it positive. That's it. Okay? Alright. First question to you is this. Which one of those 2 terms has an exponent? 1 or both?
One.
X.
Which one does? X does? So that's all I am focused on then. Is the x to the -3. And I have to make it a positive.
1 over X.
1
Oh
over
my gosh.
Or 1 over X, 2 positive.
Okay, but what about the 3?
Put it under 2.
I have no idea.
Distribute.
Like 2.
Yeah. Okay, you're very close. Yeah, you're very close. I think I know what you're saying. Okay, so if I just focus on the x right now, it would look like this. Now don't write this down. It would look like this. All I did was focus on that.
That's the answer.
I have 3, because it stays the same. What's the exponent on 3 right now? 1. If it's not there, it's not times, it's 3 to the power of 1. If it's not written there, you have to know that it's a 1. not a 0, because if it was 0, then it would be 1. It's just a 1. So this is what I have then if I focus on that. Well, what do I do when I'm multiplying fractions? Multiply the tops and multiply the bottoms. You agree?
Yeah.
So what's 3 times 1? 3. 3. There's your answer. I didn't actually need the 1 in there at all. I could have just left the 1 on top and put the x cubed on the bottom, and that's it. Yes, Brock?
If you did the 3 and then bracket, in the bracket, 1 over x to the positive 3, is that right too?
No, because I want you to understand that this also has an exponent on it. You're not moving it. I want you to have it written as one simple fraction. Okay? But you're going to get 1 mark for this. You'll get a half mark if you do that. You understand? If you go to here, you get a full mark. Okay? Justin, you got a question?
No, it was a scratch.
Okay. Yes, I'll.
So what if it was like 2 times 3 times x to the power of negative 3? Would it be 6?
Okay, hold on. Let's back it up a wee bit here.
Sorry.
Okay. So what are you looking at?
2 times 3 times negative x to the power of negative 3.
In brackets.
Like the same question, just put a 2 in front of the 3.
2 here.
Yeah, and then times that. Yeah.
Times that? Okay.
Would it be 6 over x?
Yes.
Okay.
Yes.
Okay.
Okay, I'm not gonna write that out for anybody. It's gonna confuse you, because it confused me. So at least your
I just-
question
yeah.
answered.
I just didn't know which
Okay.
one you put on top.
Yeah, no, it's fine. All right. How about this now? What's the difference between these two?
Nothing.
One's in brackets and one's not, which then means what, Danielle? The negative 2 is to both. Okay, so what is this going to look like if it's for both? Well, let's make it a positive to begin with. This is the simple thing to do. How do I make that a positive? What do I do?
The 1 over.
Put 1 over it, right? So that becomes 1 over 5x squared, just like that, right? So all I have to do is put it underneath the 1. Okay? Brock? You good? All I have to do is put it underneath 1 to make the exponent positive. And whatever the exponent's for, I have to take the whole thing with me. So in this case, this negative 2 is for everything here, right? Because of the brackets. This one, it was just for the x, like you said. You see the difference between the two?
Yeah. Well,
Okay.
like what happens when you have 2 exponents and 2 legs?
Well, we'll get there. We'll get there. Just wait a second. We're gonna work our way through number 1 here, okay? So what's my final answer here? Well, realistically, I would accept 1 over 5x squared. 1 over 5 squared x squared is also okay. I'm okay with, as long as you understand that this has to go to the bottom. Okay? Not on your paper here. I'm just gonna ask you a simple question. Anybody have questions about this or comment? No, good. I won't wait. Got that there. Justin?
Reciprocate.
Sure. That's right. How do I make a negative that's on the bottom a positive? Move it to the top of the fraction. Move it to the top of the fraction. Reciprocate it if you want. That works. 5x squared. Done. That's okay. Okay? All you're doing to make a negative exponent a positive is moving from the bottom to the top of the top to the bottom. There's nothing more than that. Alright? We okay? I'm going quickly, so if you gotta slow down, we gotta slow down. Let's look at this bad boy. What has to move here? The A and the B, they gotta move. Why do they gotta move, Gene? What's their exponent? What's the exponent on A, Jamie? Minus what? Minus 3? And we don't want a minus, do we? We want positive. So how do I make it a positive? Under a 1, or just put it underneath So what I'm gonna do here is this. Okay, Jamie, what's the exponent on 6? There is an exponent. What is it? On 6. On just the 6. Ignore this for a second. Just look at the 6. Hard to ignore, isn't it? Okay? The exponent there is a 1. If there's no exponent written, I just explained this 2 minutes ago. If there's no exponent written, it is a 1. So therefore, is it already positive?
Yes.
So do I have to move it below the line?
No.
No, so I go 6 to the 1 right there. I don't need the 1. Just put it in.
Okay.
Just put it in. Okay?
Wonder.
What goes below?
Positive 3.
A3, B2. Done.
What happens if you go A, B, 6? That doesn't work,
Nope. Brock?
right?
Why not?
Not
Because they're separate.
the bases.
Why not, Brock?
I have no idea.
Because you're about to find out.
Look at the bases.
Now just told me I'll just never do that.
Well, that's one way to look at it, Brock.
Never need to know exactly why.
Well, I'm gonna tell you why, no, Brock. It needs to make sense, okay? So what you're telling me is that's what? Well, you told me that if I add B to the 6, right? Is that what you said?
Yeah.
So is this 2, 3 to the 6? What is it? Yeah, they can't be put together, can they? Because those bases are different. So that means I have 3 2s and 2 3s, and all I can do is multiply them together. That is not 6 to the 6th, or 6 to the 5th, or 6 to the anything. It's 2 cubed, 3 squared. Cannot put those together. Because that's that, that's that. So you can't put them together. That's not 6, is it? No? So you can't put them together. Do you understand now why I can't do that? Okay, good. All right, a couple more, and then you guys can go through there. This one. This is a lot simpler than you think. If I got rid of the brackets right now, what would that read?
Minus 2 over minus 2. Oh no.
2 over 3 with
2
the.
over minus 2. No. 2 to the power of minus 2. Over 3 to the power of minus. Minus
Yes,
3.
you're right. Okay, you got it. No, you did great. You did great. Okay, it's absolutely right. What is it? What do I do with the exponent here? Distribute it. So this is actually 2 to the negative 3 over 3 to the negative 3.
Nice.
We agree? Right? That's all it just says. Distributed through the brackets, correct?
And then you flip it once and they're both positive.
Flip it once and we're both positive. 3 cubed over 2 cubed. There's your answer.
Holy.
It's pretty easy, right? Pretty straightforward. That is the easiest way to do that question. There is another way, but I'm not going to show you.
Can I see?
No, it's complicated.
Hold on. Yeah, I'm going to get rid of it. What's that?
Nothing. You said, can I see? And I said, no.
You don't understand this?
No, I see this. He said, you said you have another way to do it?
Yeah.
And he said, can I see? And I said, no.
Speaking for him, right? All right, let's look it up. Okay.
What was the big
A
one?
lot easier than it looks. A lot easier than it looks. Which one of those terms has a negative exponent only? B. So it's the only one that has to move. Remember, the negative in front of the 4
Will always say
never changes. So what is this going to read?
negative 4 a raised to the power of 4.
Just like that. Okay?
Questions?
Negative roots. That doesn't need to be.
Does it ask you for all these or
Oh
whatever?
no, you're just going, never mind. I'm being dumb.
Shut off.
Four point two.